because this is, I hope you can see it and hear it when it starts. Oh, sorry.
Ring that ring, that's the bell.
Skip that. That's not the video.
So is it too big for your head?
I'm holding it tight.
Holding it.
Good. Did you get the picture for doing that?
I'm taking a video. This is going on YouTube. Cindy, what do you think?
It's so real. And it's a picture in here, huh?
Yeah.
Oh, Lordy.
That's pretty cool, right?
It sure is. And you know what? Is it my eyes or are the leaves blowing in?
They're blowing. You're right. You see it. How cool is that?
Do you want to see the?
Oh, I stopped it. I didn't mean to stop it. But it's essentially a lot of like, oh my, you know, she's super excited. And this is her first time trying the Oculus Rift. And I love this video, even though it's quite old, probably 2 years old now, because it shows the first reaction. And my first reaction when I tried Oculus Rift was similar. I mean, maybe not as animated, but I was blown away by the fact that it was something that I didn't expect to see. It wasn't like 3D movies. And my favorite question whenever we demo Oculus Rift to new people, kids or undergraduates or grown-ups as well, is to ask whether what you'll see or what you just saw was what you expected. And most of the time people say no, because they expected something like 3D glasses in movie theaters. While here you are really, your brain is tricked into believing that you are in a 3D space, in a virtual 3D space. So that's why I love this video, because it shows how, excited this woman was. And also the potential of, bringing something so exciting to people or to this particular grandma who probably never been to Tuscany. But this was her chance to travel there and experience it, and she was blown away, but also excited to be there. So it shows like this potential of this technology and also how people react to it. So I'll go back to my slides. So my background is not in VR. I was a PhD student here in University of Illinois, and my PhD topic was on robot motion planning and a little bit numerical methods and sensing and filtering. But it wasn't related to VR. So I wanted to tell a little bit about my personal path and how my background helped me contribute to the technology at Oculus VR. And also, I want to talk about Oculus VR startup itself. Why did it emerge in 2012? Why didn't it happen in the early 2000s or late 90s? What really were the components that made this technology come back from being actually dead and buried in the 90s? So for us, for me and my husband, it was the combination of the right background and being at the right time in the right place where this technology could have emerged, and Oculus VR was also a startup in the right place in the right time. That's why it all happened. So, but let me start with my background. So, robot motion planning. I don't know if you see really well, but this is a piano in a room, okay? So the central problem in that field is the piano movers problem. You have a small apartment with lots of furniture, and you need to take that piano outside of the room. Is it a difficult problem? Yeah, it can be. It can be an unsolvable problem, because if you have too much clutter, you probably will not be able to move it. Why is it a complex problem? Well, the piano and the furniture in the room probably have complex geometry. And also the way you can move the piano, it's not only just 3 degrees of freedom of translating it, but you can also rotate it in 3 different ways. So the total number of degrees of freedom is 6. That means you have to solve a puzzle not just in 2D and not in 3D, but in 6-dimensional space with complex obstacles. So it makes it a difficult problem, and the field was developing for many years, since the 1960s. but it is in a solid place right now. So the way to solve this problem is to abstract away from the complexity of geometry to a configuration space, what's called configuration space. So in which each point is one particular place of the piano in that room and its orientation. So the green regions are the areas where for that position of the piano and orientation of the piano, it would collide with other furniture. While the white space is the free space in which you can navigate the piano out. And if you have your initial position and orientation of the piano, say here, and the goal where you want it probably outside on the street, if they belong to the same connected component of the free space, oh, I'm not drawing too well, then you can find a path. It could be that they would belong to two different connected components. The two white spaces would not be connected. That would mean that there is no solution, and you cannot. You have to move your furniture or something like that. So how is that related to virtual reality? No, before I go to that, the way of solving this problem was something that, in fact, this was the algorithm developed by my husband, Steve Lavelle. He developed it in 1998. The most successful algorithm today is called RT, Rapidly Exploring Random Trees. So they start for the white space. You grow a tree that looks kind of like fractal, and eventually it just explores all of the space so that it's guaranteed that in some time, if you have 2 points, the initial configuration of the piano and the final configuration of the piano in the same connected component, you can find that solution through this tree. So that's the up-to-date technique for solving this kind of problems. However, it works on many spaces, but something that makes piano problem related to VR is the underlying space. So I just told you that those were like green areas and white areas, but there is a little more to that. They're not necessarily Euclidean spaces, so the topology and neighborhoods that we kind of understand in 3D and 2D, that's not what happens for rotational component of the piano, which is called, that space is called SO3, special orthogonal group, special matrices with special conditions satisfied. But for a roboticist, for somebody who is trained in motion planning piano, I'm not gonna draw it because I don't think I can. But piano is equivalent to the human head. So the number of degrees of freedom for a piano, which is a 3D rigid body, is the same as for a human head. We can translate it 3 different ways, right? When we move up and down, and we can rotate it in 3 different ways as well. So this space, the underlying space structure, is the same as it was in motion planning. Which helped me. One of my PhD topics was understanding the structure of SO3 and putting grids, which would be extremely useful for doing any kind of numerical methods on that space. And it turns out that at Oculus VR, what I personally contributed was the mathematical library for describing the space for head tracking of Oculus Rift. So all of the math library, I wrote it in Oculus, and it's used in every single SDK out there today. So I'm really, really proud to contribute. And what Steve has done on top of that, he developed novel numerical methods on this space, which we also implemented at Oculus, which helped very fast head tracking, which is also used right now in every single Oculus Rift out there. So this was our contribution, and that's how it all connected, why our background was so useful over there. But we were at the right time in the right place as well. So that component was there. So I'm not going to talk, there is a lot more. This is a list of all of the relationships between robot motion planning and VR. I just mentioned one. So now I want to talk about the startup itself. Why did it become so famous and took off now? Like what were the components that made it successful or possible to succeed now? So let's start from the beginning. In 1968, Ivan Sutherland, we can call him the father of VR, developed the first VR and AR device. So VR is virtual reality, AR is augmented reality. So you can see him standing here, holding the helmet, but he's not really holding it. There is this whole structure out there that is connected to the ceiling to hold the device because it's very heavy. So it's not up to date, right? This was the beginning of it. However, what was really amazing was that he used lenses to project on the real world artificial objects, virtual objects, so that when he moved his head, well, that fixture would help to move the device itself, but the computer that was next room probably, and the size of the room at the time, would help to change the location of those virtual objects correspondingly with his head movement. So it seemed real that those objects were present. So here we go, he started it, and he really excited a lot of people. So virtual reality took off then, and there were a lot of different attempts at getting it to the consumers. So the best before Oculus implementation of virtual reality was actually developed at the University of Illinois caves. How many of you have tried caves? The cave here, right? So how was it? Did you like it? Did you feel like you're there really? Or was there something, what was it? Because there is one, well, there is drawback to caves in terms of cost. They're really expensive, but there is also something that's missing that they do not provide compared to Oculus. And I wonder if you know what that is. You probably know this.
In some cases, that tracking and position tracking isn't available.
So it's not as responsive to your motion.
Latency.
What about depth perception?
Sure.
Is it there?
No.
No, it's just missing. So if you see something, so you feel like you're in the room, and you can move, and it will move correspondingly. You can turn around, and it will really show what could be there. It's a virtual environment that responds a little slowly, but it is a virtual reality, and it can trick you from time to time. However, if you see some object, and you want to lean in closer and look at it more carefully, the depth is not there, the depth information. So that's something that's missing. And but however, it was the most successful implementation of virtual reality up to date, except from prohibitive cost, from $30,000 up to $1 million to install one with a room like that. So there were other attempts with various problems, tracking, bad resolution. So the final attempt, but there was a lot of hype also about this technology in the 90s. Everybody was expecting something. And what really killed it was the last attempt by Sony to create Virtual Boy in Nintendo. How many of you have tried that? I actually met it. Did you like it?
It was odd because everything's drawn in red.
It's red and black, poor resolution. You have to kind of, it's not really on your head, right? You have to lean in. So the whole point of virtual reality was lost. It was a poor implementation. And that's what considered being what killed virtual reality in the 90s. After that, it was kind of a taboo. For any startup to start this would be extremely risky because they would have to convince masses that they can do something much better. So Oculus Rift did it. In 2012, a lot of other things came together that made it possible. So while VR was dead and buried, the phone industry developed really high-resolution screens, which wasn't there in the 90s. Also, MEMS sensors, and I have some props here. I wanna, pass this around. So what you'll see here, let me see. These are lenses. So these will be components of the Rift. Lenses, and many of you have cell phones. So put something on the cell phone and look at the cell phone through lens and see how it just wraps around everything. And if you have high resolution screen, you can trick yourself thinking that whatever that screen shows is your reality. You have to be careful what you're going to be showing, but they hide on many levels. But the main point is that if you have high resolution screens, you will not see pixels. And it will make it much more believable. Also, so this is the Rift itself, what it has. Inside, I took one of the lenses out and I'll be passing it around, but you'll see the phone inside. So the phone, the screen itself is one of the components. The lenses that wrap it around you is another component, and then the third component, so I'm going to passing this around as well. Sorry about that, I don't know how to disconnect. So there's another lens. And I have the sensor board that was actually custom made at the Oculus with 3 different sensors here. I'll show them on the screen as well. There's magnetometer, accelerometer, and gyro. And this was just not possible in the 90s either. The cost of it is under $3. They are very reliable and small and light. So this is something that if you put on the phone, which projects some virtual reality, it'll help you compute where the head is looking after some rotation and translate. Well, this will not help with translation, but with rotation, so that you can update the view and fool the brain that you're actually looking at the real thing. Just like when our vision works, when we rotate head, the screen is updated to the real screen, right? So here we go, we have some sensors to pass. Sensor boards. So here it is. So these are the 2 components that were missing in the 90s, but suddenly, they're just available and cheap in 2012. Also, there's this guy, Homer Lucky. He's 19 years old, homeschooled, and fits his phones to make pocket money. With that pocket money, he has a hobby of buying virtual reality headsets that existed and sold for almost nothing on eBay because nobody cares, right, anymore. And by fixing screens, I think he kind of got this idea that, well, the technology is different nowadays and he could do something better. So he created the first prototype by just putting the screen and lenses together and having that feel of actually having something better than all of the previous headsets. So, Carmack? How many of you know that guy? Because I didn't.
No, of him.
Of him. Did you know of him before Oculus? Yeah, he is a JC for gaming community. Because he created he was the first one who created Doom. Doom is the big thing for many generations, I guess, or just one generation, I don't know. I played Doom, but I didn't know about him. But he has a following. So once he got his hands on this prototype and he announced to his followers that this is a great thing, there was a lot of interest in the gaming community, which was a great business plan for this startup. And I want to say here that even though the gaming community and gaming industry was something that took this startup off, I see the main applications not really in gaming. But we should be grateful to those guys who really made this happen at the time. So what happened after that, a couple of game industry guys who very successful business people who sold some, middleware for gaming, successfully sold and led that development. So they decided to start to create a Kickstarter and make a startup. So this was like 5 guys plus Palmer 6 guys. They made a Kickstarter movie which raised $2 million, far more than what they expected. I think they were shooting for 400,000. I don't remember, or 400,000 probably. So that's when they invited. I don't know how they found. I mean, I know, but they found Steve. And Steve didn't want to really do any consulting, but they needed consulting with those spaces that I talked about, the math library for the orientation of the head to do head tracking. And Steve was kind of busy, but I was really not looking for something to do, so we decided to consult for them together. And that's how we joined them, because after a while of consulting, we tried the Oculus Rift, we got excited, and we just believed in it as well. So we were 7 and 8 people to join it. And once we joined it, it took 1.5 years to take the startup from $2 million to the $2 billion purchase by Facebook. So this was the fastest growing startup in the history of startups. And that was a wild ride. So now it's Facebook. We're back at Illinois. And I want to talk about, I don't know how much time I have, but I may probably want to talk about the future. And I'm going to skip a little bit about the Oculus itself because you guys have those problems. I already talked about it. I want to talk about what I see for this technology in the future. And our main goal is to educate the future generation how to use this technology and develop the best possible experiences for a variety of applications. So I want to talk a little bit about that. I'm going to skip a bunch of, that this is just explaining what are the components and how we put all of these things together to do head tracking through the sensors that are there. So let's talk about applications. What can be done? Travel. Just like that grandma video where she went to Tuscany, you can travel to existing and non-existing places. Places in the past, nature, places that maybe existed but were destroyed, which is one of the projects in the current class, VR class in CS department. It's a Syrian palace that was recently destroyed by ISIS group. And, but the 3D model is available, so we can recreate those places through VR and you can visit them again, even though it's extremely sad that they don't exist anymore. So virtual travel is one of the applications. What is it? Real estate. Real estate tours. Something as simple, but can be quite exciting as well, because you can really see what you're buying before buying it, right? Or before even looking to go there to the house. A lot of medical applications, from virtual surgeries that were already attempted and tried. That was a big news like a couple of weeks ago, at least I saw it. Treating different kinds of phobias, fear of heights, fear of spiders, attention studies. A lot of these things are already going on here in Illinois through different collaborations with the help of the VR class as well, which helps bring different departments together. So one of the projects that I've seen done was hooking up this EKG helmet together with the Oculus Rift, as if the Rift is not big enough, to measure brain activity while studying attention that is in the scenes that are generated in the Oculus Rift. So they got some good results, and they're gonna keep pushing that research. So and maybe more in medical applications. So I'm just scratching the surface. New projects pop up every day. Sometimes students in the class just come with their own ideas, which is really exciting, because maybe they have other kind of perspective on certain things. 3D design, I'm really excited about that. We already have a student working over the summer who will take the class next semester. So you could create different kind of 3D shapes in VR without wasting the material, and then only after you're done, 3D print it. So a completely different process that that didn't exist before. in this way. What else? And I want to just say that also I believe it's going to help us to bring us all even closer, because it's not only virtual travel to places, you can meet people that are on different continents and really feel you're there, as well as educate kids by immersing them in different countries, environments, and helping them study different foreign languages. So I think this is the reason why Facebook bought this technology, because they're interested in connecting people, and it will help connect us even more. So I think I want to stop here, and we can take questions and talk more. I'm not too early. Yeah, I'm done. Okay. Questions? Yeah.
I'm really excited about the notion of how this application could fit in terms of the education and educational curriculum. Have you guys kind of mapped out some of the ways in which this technology can be integrated and utilized in an educational context?
I am not involved in that project, but Steve has started education in foreign languages project. I think it took off, it got grants, it got funding, and what they're going to do, but this is foreign languages education. So it's very different from using it, say, in the classroom for teaching CS. So what they're going to do is to do some kind of exchange between students in Mexico and students in the US to help both of them. I think they're much more interested in studying English than we are studying Spanish, though. But it's still okay. There is still funding for doing that, and by providing cameras in one place and Rifts at another place, these kids with the Rift can feel that they are in a classroom or they are on a field trip, buying, say, I don't know, some candy in Mexican store, and studying Spanish. So that's what has been done.
So using it as a tool, but
tool
not
for
necessarily
immersion.
for the technology itself.
Not for the technology itself, it's just a tool.
Okay.
Just a tool to provide the immersion, because studying foreign language seems like a very natural fit, and true immersion helps you facilitate the learning in that context. But I can imagine that history could be taught with the help of this tool as well, by providing places where events happened, but we haven't pushed in that direction. But I can see how project can just happen.
Thank you.
Yeah, you had a question.
Are you trying to reduce the size of the equipment?
Reduce the size of the equipment. I believe the consumer version is going to be released in next. I think they just announced that it's going to be next January, and I believe it's going to be lighter and higher resolution, but it's still going to be a box, so not much smaller. That is not there yet. It's not Google Glass, which is really, really tiny. So because this has to have a code, it has to have so large.
What is the cost to the consumer?
I think it's going to be $450. Currently, the dev kit is $350. So it's really cheap compared to whatever existed before.
Yeah. What's the top commercial use of the technology right now?
Video games.
Still.
First person shooter, right? So Chris here, actually you took a class current class that Steve was teaching. Both me and Steve are really invested into teaching everything that we know and learn more as it emerges, to inspire new projects and the best possible experiences in VR, because there's a lot of problems there still.
So besides video games, because I know one of our portfolio companies does, it's virtual shopping. It's used for market research. We're going into a store and what are you picking up and what are you looking at and all
I
that.
can see how that.
And so, and I know that I don't know how far they've gotten with the Rift.
With the Rift already?
Yeah,
Here?
it's in Chicago, but they've been using it, certainly in demos with their clients. So,
Yeah.
I mean, other than gaming, what are some of the top uses commercially?
That's a very good question. So what we do, we Google, Oculus Rift together
Yeah.
with whatever topic, and very
Yeah.
often there's something that's being going on.
Yeah, that's
I
what
don't
I
know how
just
to
did.
rank them.
Because I had seen the demo, but I didn't know for sure
There's
that
a lot
was the
of them.
technology,
So what I know is that a lot of car companies, they do virtual tours in their cars and virtual driving experiences, and that was commercialized already. I don't know how big it is. So that's a good question.
Yeah, it's just interesting to see which industries would adopt this first and why.
Yeah. I guess, it would take some research, so because they're all independent. Yeah.
So along the ways, we have something similar in our company, but it's more like the cave, and it's like a portable system.
Mhm.
One thing we had issues with is that sometimes you get nauseous if
Yeah.
you're not careful and too fast. Is that something that people experience with?
Yeah, so motion sickness is one of the biggest problems in this kind of in virtual reality. The reason is that we are tricking the brain with the visual stimuli, but not with the vestibular stimuli. A person is usually not walking up the steps when it happens in virtual reality. We are still sitting in the chair or standing, as in the case of the cave. So the inner ear does not detect acceleration while the visual stimuli says otherwise. And that's what evolutionary caused humans to have a natural reaction of feeling nauseous. Because if the visual stimuli do not respond to the vestibular system, means that you ate something that is bad or poisonous, and the natural reaction is to feel nauseous. And that's something that needs to be worked with. There are a lot of tricks, and one of the components of the class that we are teaching is to include perceptual psychology into the curriculum to understand what it takes to trick the brain, and that is, the different field that we are not experts at all, but definitely needs to be included. So one of the many ways to trick it now that we know is to not allow a person to move in the environment. A lot of experience can be done by teleporting to places. If you want to visit a place, you can be just teleported from place to place and look around and move just very locally. And that will avoid nausea quite a bit. What else? Well, mostly, yeah. Or sorry, that's another thing that I wanted to say. Moving at a constant speed versus with acceleration, like starting to move and stopping. Just like a train ride through some environment, like for real estate, for example, is something that would reduce motion sickness quite a bit.
And rotation
Also,
too, right?
rotation does not cause any, because that's angular velocity. So that's fine. While you're moving your head, the ear detects it because you are moving it. So rotation does not cause motion sickness. It's the translation that you're not actually doing in the physical space, but trying to do in the virtual space. That mismatch causes the motion sickness. So yeah, lots of tricks. So a lot of experiences, if you know what you're doing, could be done in a way that would be pleasant. If you don't know what you're doing, which we are trying to eliminate with this class, teaching students what can be done to avoid all of these issues. If you don't know what you're doing, you can make an experience that is terrible for you. Yeah.
So I guess given the immersion that's capable of virtual reality, do you think that virtual conferences have advantages beyond traditional video conferences?
Virtual, yeah, I would love to do that.
Maybe.
Yeah. Steve has done virtual, I think when he gave a talk here, I was just talking to a person who was in the audience, and he said that, so he was doing, there's the Second Life community, and they have this Second Life software, where you can do a lot of things, meet people, but also do conferences on different topics. Steve was invited to one of the conferences when they also put a mod for the Rift. So he was there, seeing all of these artificial people, avatars of other researchers, and he gave a talk to an artificial audience. what was amazing for him is that his memory of that event was as if it was a real conference. As if he actually met all those people, even though all of them looked like silly avatars. So there's something to it. It's not a video conference. You really feel present, like you just talk to people. So I see advantage of it. Of course, there are lots of challenges how to create avatars that actually make sense. Yeah.
I'm wondering if some point in the future it will be implemented into disability to change their life.
It's already going on. So if you Google Oculus Rift and disability, yeah, they're doing it for people who are immobile for one reason or another. This is a great experience to have. It improves their quality of life. For people who had some traumatic experiences in the past, it's also used for therapy to, to provide experiences to relive whatever was traumatic in the past and conquer it. Just like, I showed tightrope walking for heights. So it could be very therapeutic. It can be used for therapy. So pretty cool, yeah.
Do you still have a relationship with the company now that you're?
It was a breakup. Okay, it was a breakup, but it was a really clean breakup, so we have very good relationships right now. They are interested in. We do not necessarily agree with the ways the company became after being acquired by Facebook. It's a corporate company now, so it's a different management style. Everything is different. However, the common goal is to make VR, usable, and we still believe in the same kind of idea that it's going to be big.
Do you see space for other companies to get into?
Yeah. Oh yeah. I think there are already serious competitors to Oculus, such as Valve HTC, which has really cool technology that Oculus could have designed. Things were different, but yeah. So there are competitors. What I really still believe in is virtual reality, that it's going to be there, it's going to be used. Which one of them will stay on top, I don't know. Yeah.
So with your breakup with the purchase from Facebook, as you're doing this research, is this incorporating, are you still sharing that information with Facebook? Do you have that level of relationship, or are you doing this independently?
Independently, completely independently. They are interested in such things, so we are kind of evangelists of VR, so they're very interested in supplying the sets for educational purposes. So I believe it's a really good relationships because we want to teach it and tell about it, and they're happy to provide technology to.
So these are fully immersive VR type. Is there any effort to use this technology in AR or something?
In AR, yeah, you can do see through. If you put cameras on it, you can actually augment send the reality to the screen.
But it's all through the camera, nothing.
Through the camera, yeah, not directly, yeah. Because your vision is blocked by the phone, so you have to capture it and send to the phone again. If you want to put something on top of it. But I've seen it done. It wasn't the best experience, so. Have you seen it done too? Yeah. It was a little delayed because I guess there is just a lot of information going through.
Thanks.
Yeah.
Do you see the biggest opportunities in the space of imagination and use of applications, or more on the hardware side, size and weight sorts of considerations?
I think it's applications.
Okay.
Yeah. I think it's a really simple technology. And it's been put together. So I don't see how much more it can be improved. It's more a question of mass manufacturing. And except for one thing, as I said, there is a competitor to Oculus in the sense that Valve designed a technology that makes it easier to capture not just human head, but also other parts easier.
Which is very challenging, right?
Which is still a challenge, yeah. So who's going to win? And when are we going to be fully immersed with all of our bodies? Because right now there's no body. Or if there is, it's kind of creepy. So that is not there. But But what I see more is applications. I think you can achieve great applications without all that other inlines in hardware. Yeah.
How's the battery/power situation? Obviously, if you're not moving, you could have it plugged into the wall or something like that. But if you want to do something like lateral motion, how much power does it take to keep the phone with the constant video?
So that is a very good question because this Oculus is powered by PC, so you're not really allowed to move much further away. There is a mobile version developed together with Samsung, and I've never tried it. So I don't know if there is some high power computation going on, depending on what it shows. I don't know how long that phone would last. Is it half an hour or 6 hours? So something that I just wanted to look up, but we don't have a hand on that technology. In fact, we were just talking with Steve about giving better presentations would be great to have those Gear VRs, so that I could pass along those phones and you can just experience it. But then both of us didn't know the answer. Would it last through the presentation due to the power? So something that. But there is a mobile version as well. But I think it can get there. So the question is probably it will, but just right now I don't know. Do you know? I don't know.
It has a few hours.
A few hours. Okay. We don't have it in class.
No.
Yeah. So it's something that we need to get it and kind of get more familiar with that.
Any last questions? All right, well, thank you, Anna. It's been great.
Oh yeah, you know what? I wanted to say something so I have a mentor who really inspired me. For many years I was the only girl in research lab, in Oculus, and then I came here to teach back to Illinois, and Cinda Hearing, probably some of you know her, she really helped me with, just being a little more confident. Because being just one girl is not always helpful for confidence. And she asked me about this presentation, and she said that a good message would be also the fact that we were at the right time in the right place, but we also took the risk, which was a really big component. We had to kind of, leave university without without knowing whether we will be able to come back or not, drag kids through continents to get to California. But we really believed that it was something new and exciting. Not many people, and even in our family, believed in that. So we took a risk and did it. And Cindy said that it's important to send that message because women are less likely to take risks. And I think it's something that maybe we should do. So anyway, that's a message from her.
Thank you. Yeah, Cinda unfortunately couldn't be here, but we're hoping that she's going to get more involved in what we're doing out here.
She's a great advocate for us.
Thank you again.
Thank you. Thank you.